absolute value, and we have to start with the absolute value. So let's start with the absolute value. 2x cubed minus x squared. Do not write the two options just yet. Let's talk about it. I see the binomial inside and the absolute value, and I say, I know what I have to do. And I think you know me a little bit, and my keywords are simplify and factor, of course. So what do you think I am going to do? I will?
Factor.
What will I factor out?
X squared.
Right. I cannot take it out from the absolute value. That is not possible. I'm not allowed to do that. The absolute value symbol is not a grouping symbol. What is left in parentheses?
2x minus 1.
2x minus 1. Remember, one of the properties of the absolute value, and thank you for asking this because I need it in 2.4, so I'm going to reuse this property several times today. So the product, the absolute value of a product is the product of absolute values. The same with a ratio. The absolute value of a ratio is the ratio of absolute values. So these are the very important properties of the absolute value. Now, I will continue using this property, the product one, the top one, and what will you tell me to write? You will say, times? Awesome. Now I'm going to ask you, I'm going to say it's perfect. You applied the property perfectly. But do I really need absolute value on x squared? No. So that's x squared 2x minus 1. So coming back to our limit, I am really facing this. Limit as x approaches 1/2 from the left, from 2x minus 1 over x squared times the absolute value of 2x minus 1. This is my limit now. I simplify the bottom. X squared doesn't need the absolute value. So then, in order to simplify this function first, I'll start with 2x minus 1 in absolute value. Remember, I have to write it 5 times. 2x minus 1, 2x minus 1, 2x minus 1, 2x minus 1. By simply using the absolute value definition, the formal definition. I have to write it 5 times. In the function or in the expression, and then 4 more times. 1, 2, 3, 4, 5. And this one has minus in front. Remember, I will refuse to solve this. There is no need. You don't have to cross it out like that. I'm just trying to trigger your memory for the future. And then I know this is 2x minus 1 for greater than or equal to 1/2, and negative 2x plus 1 for less than 1/2. Now I can put all pieces together. So let's put all pieces together. And that function. So let me refresh your memory. The function was this. If it has an absolute value in it, it must have 2 options. 1, for x greater than 1/2, I refuse to copy the equal symbol, and you'll tell me why I'm refusing to copy this equal symbol. Why am I refusing to copy the equal symbol? I had it over there, but here I refuse to copy it. Yes? Of course. Absolutely. So in this expression, there is no denominator. So this is correct. But here, 2x minus 1 is in the denominator. I cannot accept 1/2. Perfect. So can anyone give us the simplified form in the first case? In which this is 2x minus 1, this is 2x minus 1, and this is x squared. 2x minus 1, this is at the top, 2x minus 1 in the denominator. These go away. What is left? What is left from the top? No. 2x minus 1 and 2x minus 1 go away. 1 divided by x squared. Thank you. Good. Now I have 2x minus 1 at the top, but I have the opposite of 2x minus 1 in the denominator. This will still go away, but something else is left over, though. Negative indeed. Finally, we simplify the function. Go back to the limit. I'm asked only the limit from the left. Okay, so limit as x approaches 1/2 from the left, from 2x minus 1 over x squared to x minus 1. I really wanted to copy it one more time, but please tell me which branch will you use? Because now I don't need this. I already worked on it. I simplified it fully. Which branch? Yes, negative 1 over x squared. Okay, finally, what is the answer? Yes. When x approaches 1/2, this is 1 over 4. I flip and I get negative. Very good. That's it. So the answer is negative 4. Very good. Any questions here? Yes, please.
For the 1 over x squared and then the comma, is it x greater than or equal to, or is it just greater than?
I cannot have equal to because this is in the denominator now.
Okay.
If I allow 1/2, then the denominator will be 0.
Okay.
But here I have to allow 1/2 because there is no denominator here. So this is correct.
Okay.
The absolute value of 2x minus 1 can have 1/2. But here, this expression or function cannot have 1/2. It's not defined at 1/2.
Okay.
Of course, you can also say yes, but you also can write x not equal 0 here. That's fine. We're not in. It's good to write it, but the question was left and right of 1/2, specifically left of 1/2. Very good pick, Becca. Thank you. I needed this because of what follows next. Section 2.4. So between now and Sunday, please finish 2.1, 2.2, and 2.3. Hopefully 2.4, we'll see. Okay? The precise definition of the limit, or also known as the epsilon delta definition of the limit. What is this all about? It's a slightly deeper understanding of when the limit exists. It's a mechanism that we use to show why the limit exists, if you want. I would waive the left-hand side and the right-hand side limits. I would waive the infinite limits. I would waive the quadratic functions or anything else. But I would like you to show me this mechanism for the simplest possible function that exists, which is linear. It will look difficult at first. I will repeat it many times. And you will see it's really nothing. It really is nothing. But at first, it will appear to be very difficult. Difficult to understand, maybe, for some. Okay? Please bear with me. You will see at the end of the day, you're going to say this is the easiest of everything we've studied so far. But not at first. Okay. Let's look at two examples side by side. This is one, and this is the other. A function here. Of course, our best friend now is what here? Of course, this is our best friend now. And followed by another best friend that goes with A. This is, of course, of course. Okay. That's another function. And let's say this is L. Can anyone tell us the difference between these two situations? One limit exists from either side, obviously, it's L. And the other one, the limit from other side of A does not exist. Awesome, very good. Okay. I would like us to use 3 mathematical notations, symbols. This symbol stands for any or for every. It's something that I did not come up with. It's well known in math. This symbol, E backwards, there exists. Oh, there exists if it's more than 1. And this symbol, such that. Do you have to memorize these 3 symbols? No. Do you have to use them? No. But you have to use the definition. If you don't want to use the symbols, fine. Just write it in plain English, though, which I think is much longer than just using those 3 symbols. But it's up to you. No one will test you on these 3 symbols. It's up to you if you decide to use them or not. Okay. So coming back here, I'm going to give you the mechanism, and then I'm going to put it in writing. And then I'm going to read it again, and then we'll talk about it. We all agree that this limit of f of x as x approaches a from either side is L. We agree. And here is the reason why. Here is the reason why. So please, I'm going to enlarge that. Because I don't want to go back to that page. So here's the reason why the limit exists. Let's suppose I create an interval that is a symmetric interval around the L. Let's say if L is 5, this is 5.2, and this is 4.8. So this length, half of this interval, is epsilon. This upper number will be L plus epsilon. What will be this lower number if the interval is symmetric? L minus epsilon. Okay, so let's suppose I come up with an epsilon. Positive, of course. Epsilon must be a positive number. And we say epsilon for any epsilon near L, meaning I'm creating an interval that is symmetric interval around L, L plus epsilon, L minus epsilon. Follow the mechanism for a second, please. From this point, I draw a horizontal line. It meets the graph at this point. And I come down with a vertical line at this point, where the x-axis is. I will repeat horizontal line. It meets the graph. I come down and I get the x value on the x-axis. Which of these two pieces, this piece, I know it's a silly question, but I'm making a point, so bear with me. Which of these two pieces, this one or this one, is the smallest? The right one, correct? So let's say I'm going to measure this. I'm going to make a symmetric interval around A such that this is A minus delta. And this piece, obviously, if I want a symmetric interval, what could it be? A plus delta. Okay. Coming back, the limit exists because for every epsilon near L, as small as you wanted it to be, you can zoom in forever. I can make it as small as I want. I will be able to find a corresponding delta. This delta depends on epsilon. If epsilon is here, this will be my delta. If epsilon is here, this will be my delta. If epsilon is here, this will be my delta. So for any epsilon, I will find a corresponding delta. And now the key, such that if I pick x here, where will f of x fall? Definitely within epsilon of L, not outside of the interval. Why? Because the limit exists. So let's write it, and then we'll explain it again. So now let's put it in writing. And I will come back to this example, the counterexample, in a minute. So limit, this is the entire definition. We have to write it every time. Every time we are using the definition, we are asked to use the precise definition of the limit to prove that this is correct, or the epsilon definition, epsilon delta definition of the limit to prove that this is correct. We have to write the definition from scratch. So this limit of f of x as x approaches a is L. I have to write the double equivalency symbol. Double equivalency symbol, which means I have two steps of the proof. From here I get this, and from here I get that. Both ways. I can start here and I get the other side. I can start on the other side and I get this. They go both ways. So the limit of f of x as x approaches a is L. Means for every epsilon greater than 0, I'll continue underneath, there exists a delta positive, of course positive, such that, how do we write the distance between x and 0? Because I need something here, but I want to explain it before I write it. So the distance between x and 0 is written as we know, the absolute value of x, correct? That's the distance between x and 0, correct? How do I write the distance between x and a? Right, that's the distance between x and a. This will be the distance between x and 0. The distance between x and a is the absolute value of x minus a. The distance between x and 0 is the absolute value of x minus 0. So coming back, such that every time I pick x close to a so that the distance is less than delta, what will this imply is that f of x, the distance between f of x and L, will be less than epsilon. I know it looks gibberish. Let's go back and re-explain and go back to the definition. Okay? Bear with me. The limit exists because for every epsilon, as small as you wanted it to be, or as large as you want it to be, but that's not the point. The point is to make it as small as possible and show that the limit always exists. So for every epsilon, we will find a corresponding delta near A such that every time we pick x within the distance between A and delta, right? So in other words, the distance between A and x definitely has to be less than delta. The f of x will fall within epsilon. Epsilon, the distance between f of x and L, will be less than epsilon. So for every epsilon greater than 0, I will find the corresponding delta such that every time I pick x so that the distance between x and A is less than delta, that will always result in the distance between the function and L less than epsilon. Did it start making some sense? So epsilon, for any epsilon, I will find the corresponding delta such that whenever the distance between x and A is smaller than delta, the corresponding f of x, the distance between f of x and the limit, will be less than epsilon. Here's what happens if by mistake I choose the largest of the two. You can say, use this. I can't, because I could pick here, and this is outside. This is still inside, but if I pick here, look what happens. It's outside of epsilon. So that's why I always have to pick the smallest of the two that I get. I cannot pick this, because if I pick x within delta away from A, this is outside. It does not fall within epsilon away from L. I'll come back. We'll look at an example, but I want to show this for a moment. I claim that this limit exists. You can say you lost your mind, but I'll show you that the limit exists. I'm going to pick this epsilon, and I'm going to show you that I will be able to find the delta. I'll choose the smallest. Here's my delta. And look what happens. If I pick x here, f of x will be at a distance of less than epsilon to L. The limit exists. And you should say not so fast. You picked a specific epsilon, but you did not think of the symbol. It says for any. For any. But see, I showed you it exists for a particular epsilon, but look at this epsilon. I cannot show you the interval. There is no interval around A. So the limit exists only if the mechanism works for any epsilon. This works for 5 epsilons, but not for the rest million. So the limit does not exist. Here the limit exists, because I can show this mechanism for any epsilon I want. As small as I want it to be, I will find the corresponding delta such that whenever I pick x, f of x will fall within epsilon, away from the limit, because the limit exists. Okay, enough about talking about this. So let's look at an example. Very simple one. Let's say 16. See how it works. On page 117. Limit 2x minus 5 equals 3 when x approaches 4. Let's see how the problem is phrased, so we know what we're trying to do. Ready? Prove the statement using the epsilon delta definition of a limit and illustrate with a diagram as we just did. The same diagram. It's just where we have to graph the function and show the 4 and show the 3 and show the interval. And we can do that. We just did it for another function. We can do that for that. Ready? So, first of all, is this correct? Is this true? Plug it in. We know. Plug it in and tell me if it's true. Is it? Of course. So now we write the double equivalency symbol for every epsilon positive. Oh, I forgot to ask you, what happened? What is this? Everybody knows that the absolute value is greater than 0. Why do I need this? What is this for? What's that? That's redundant, right? I know that the absolute value is positive. It's not redundant. It means you cannot pick x to be a. This has to be strictly greater than 0, not 0. But we know we can pick x to be a. X approaches a, but we cannot pick x to be a. That's why this is extremely important. That specifically says x is close to a, but you cannot make it a. That's why we need that. Clear? Okay. I think I have 2 pages here. Yeah, I do. So for every epsilon greater than 0, can anyone help? We will find, or there exists, what? A corresponding what?
Delta.
Positive, very good. Such that whenever we pick x minus, and now I have to replace the corresponding a. For our problem, what is a? Excellent. Less than delta. This will always imply, always, forever, because the limit exists, will imply, now I need f of x.
X minus 5.
Awesome. Minus, now I need the limit.
4.
Careful. Yes, the function goes with L, and x goes with a. Less than. L and the function and epsilon are together. X and a and delta are together. Less than epsilon. Very good. Okay, step 1. There are 2 steps here. One from the left to the right and the other one from the right to the left. Ready? We start here. And we write 2x, what is this? Well, I expect for someone to say that negative 5 minus 3 is minus 8. Good, that's all I wanted you to say. What do you think I'm going to do next? Look inside and say, I know you are going to factor out a 2. That's the only thing, it's obvious, right? Okay, so what is left? Very good. What do you think I'm going to use next? Becca just suggested that example, and I said, thank you, because I needed this now. She suggested an example a few minutes ago. So I have to use a property of the absolute value. I cannot factor out. I cannot put anything in. It's the absolute value. It's not a grouping symbol. So then I write the absolute value of 2 times the absolute value of x minus 4 less than epsilon. Now I'm going to ask you, okay, what is the absolute value of 2? 2 times x minus 4. Remember, this is what we are after. And delta will depend on epsilon. It's dependent on epsilon, not on anything else, not on x, not on anything else. So what do you think I'm going to do to both sides? Divide by 2, very good. Please compare these two and eventually give us delta. And that's all we needed to do. How much is delta? I mean, we know how to compare these two, right? So how much is delta? Indeed, epsilon over 2, of course. In other words, if I say epsilon is 0.1, can you find the delta? What will it be? Over 2. Okay? If I say epsilon is 0.01, what will you say? 0.1 over 2. And can I go on forever? Why I can go on forever? Because the limit exists. Can pick any epsilon I want. The corresponding delta is epsilon over 2. So part 2, I have to show that delta equals epsilon over 2 works. I don't want you to do anything else, just write by reversing the steps from above. That's all I want you to write. What should I do? I'll start here. I'll multiply both sides by 2. I'll put the absolute value of 2. I'll change it into this. I'll change it into this, and I'll change it into this. There is no need for you to copy. I'm happy with just writing that. Yes, it's more complicated and a different mechanism, slightly different mechanism if the function is quadratic. I'll give you this easy. If the function is cubic, and so on and so forth. I'm only interested in one simple proof with a linear function. We have time. Let's choose another. Let's say 20. Draw my attention. Same page. 117. I know initially it looked terrible, but I'm sure. Is it 10? Yes, it's 10. In parentheses, 3 minus 4/5 x equals -5. Now I would like you to walk me through the steps here.
Such that.
So, first of all, let's check. Let's make sure that this is okay. Is this okay? So 10 divided by 2 is 2. 2 times -4 is -8. 3 minus 8 is good. Very good. So the equivalency symbol, and I'm waiting for you to tell me what to write. For every or any epsilon positive, there exists, I will find what? A corresponding, also positive, of course, such that, yes, 0 less than the absolute value of, and now I have to be careful what to replace and where. Remember, x, a, and delta work together. The function L and epsilon are together.
So 3 minus 4.
X minus 10 in absolute value. Less than delta will always imply, for sure, the distance between, yes, which is?
3 minus 4.
Very good. 3 minus 4/5 x. Minus? One more time. Let's write it down. A, x, and delta are together. L, the function, and epsilon are together. You cannot mix and match. So the function minus, yes, minus -5, which is 5 in absolute value, must be less than. Exactly, because the function L and epsilon are together. The function A and delta, the x, A, and delta are together. Do not mix and match. Where is our starting point?
the end.
Right, the end. So let's simplify before we write it. I have negative 4/5 x and then plus 8 less than epsilon. What would be the next step? Definitely, I need to find the least common denominator. Very good, which is, there is only one, so 5, very good. The adjustment for the top of this, very good. Please give me the numerator. Very good. Next step, you know what we're after, right? This is what I'm after, but I haven't gotten there yet. Next step, please. What will you say? Factor out negative 4. Careful. Look at what we're after, right? Keep this in mind.
X minus 10.
X minus 10, of course. Now we have to use two properties of the absolute value. The absolute value of negative 4, the absolute value of minus 10, x minus 10, the absolute value of 5 less than epsilon. But we know that the absolute value of negative 5 is, I'm sorry, the absolute value of negative 4 is, good. And the absolute value of 5 is, of course, I need to solve for the absolute value of x minus 10. Please tell me what to write. And what operation will you use?
Divide by 4.
You will multiply both sides by the multiplicative inverse.
Right.
5 over 4, correct?
4.
So let's multiply this side by 5 over 4 and this side by 5 over 4. So we have 5 epsilon over 4. Therefore, delta must be 5 epsilon over 4. In step 2, show that delta equals 5 epsilon over 4 works by reversing the steps. Reversing the steps. You do not have to write anything else. Just write by reversing the steps, and I'm fine. It's a simple mechanism. For these kind of functions, it's a simple mechanism. For others, it's not that simple. To show and find the corresponding delta. I would like to look at, we still have 5 minutes, so let's look at a numerical example. And that completes 2.4. That's all I need. Okay, so here's an example. I hope we can finish it in 4 minutes, 5 minutes. Okay, so let's see what we have here. Use a given graph of the square root of x to find the number delta such that blah, blah, blah. So this is x. What is this? A. Very good. Right here. The square root of x is the function. What is 2? The limit. Very good. Can anyone give us epsilon? What epsilon is given here? 0.4 indeed. Very good. The distance is 0.4. The distance is 0.4. Obviously, epsilon is 0.4. Perfect. So that's what it is right here, epsilon, 0.4. It says use the given graph and to find the number delta such that. So let's do that. So we are given x minus 4 less than delta. And this is problem 3 on page 117. And we have the square root of x minus 2 is less than 0.4. And we are given this graph. The square root of x is this graph. And we have 4. We have 2, 2.4, 1.6. And we're asked to find delta. Okay, so we start like we normally do. Where? From the end. Function minus L less than epsilon. That's where our starting point is. So the square root of x minus 2 in absolute value less than 0.4. How do I solve this absolute value inequality? Anyone remembers what to write next? Yes, please. Negative 0.4 less than the square of x minus 2, less than 0.4. Next step. Do we remember this? Are you with me on this one? Say no, and I'll explain how we got this. Yes? Do I need to explain? Do we know this? Okay, perfect. So the next step would be to add 2 to all 3 sides. So if I add 2 here, so add 2 to all 3 sides. So I get 1.6 less than the square root of x and less than 2.4. Remember what we're after. This is what I'm after. As long as I get the absolute value of x minus 4 on this side, I'm done. I'll get delta. Very good. Next step. I will never ever say square all 3 sides of an inequality. But this time I will, because all these numbers are positive. So if 2 is less than 5 is less than 9, if you square all 3 sides, you will still get a correct statement. But otherwise, you're not allowed to. If any of this contains a negative side, you cannot do that. Okay, so this time we are going to square. So 1.6 squared less than x less than 2.4 squared. And then, I know it's we're almost done. I would like you to subtract 4 from all 3 sides. And then we'll finish it on Tuesday. So, now if you want, we can finish it now. Where is my calculator? I don't want to hold you over. That's my only concern.
2.56 is less than x.
So we have 1.6 squared, right, minus 4. And we get negative 1.44. Less than x, of course, x squared. I'm sorry. See, I'm rushing now. I already squared that. Yes, I did square everything else. Okay, so less than, how much is 2.4 squared and minus 4? 1.76. Good, we're almost there. Minus 4 from all 3 sides. Now I have to use the smallest of the 2. So from here, I have 2 options. X minus 4 is less than 1.76, or x minus 4 is less than 1.44. Because this will change into negative 1.76 less than x minus 4 less than 1.76. And this will change into negative 1.44 less than x minus 4 less than 1.44. I have to choose the smallest, as we did before, delta. So which one is smaller? Good. delta equals 1.44. Any questions? Yes.